Hello students, welcome to Akshara 8 Foundation. So today we are going to discuss about the topic energy. Okay, in the last class we have discussed about the work. Okay, so now today we are going to discuss about the energy and types of energy, their expressions we are going to see here now. So what is the energy there? Okay, energy is nothing but the capacity to do the work is called energy. Okay, so energy is known as energy, the capacity to do the work, to do the work is called energy, okay. The capacity to do the work is called energy, okay. So then energy is also, this energy is same unit sign, SI unit of energy, same units and dimensions as work. Okay. So in the previous class we have discussed about the work. The SI unit of work is what we have seen there, Newton meter, that is nothing but joule. Okay. Here energy also. So here the capacity to do the work. So that is called energy. The energy is equals to work done. Then SI unit of energy is SI unit of energy. SI unit of energy is joule. We write here joule. That is nothing but here Newton meter. Newton meter. So now the dimensional formula of this, dimensional formula of energy. Dimensional formula of energy is, so here joule, Newton meter is nothing but kg meter square per second square. So here we can add there kg means a symbol of mass, that is 1, m power 1, capital M power 1, and meter square is nothing but L length power 2, and time second square, second per second square. So t power minus 2 will come there. So this is a, so it is dimensional formula is same as the work done. This is the scalar quantity. This work done is, work done is a scalar quantity. Scalar quantity. Scalar quantity. Work done is the scalar quantity. Okay. So then we have commercial unit of work done is there. Commercial unit of energy. So commercial unit of energy. So commercial unit of energy. So commercial unit of energy is commercial unit of energy. That is kilowatt hour. Okay, kilowatt hour WH. This is nothing but here kilowatt hour. That means the energy consumed by the body, energy consumed by the body, okay, energy consumed by the body in watt hour, okay. So total the power, the electrical energy consumed by the, or we can say if it is electrical energy, commercial unit of electrical energy. If it is electrical energy, then we will say here kilowatt hour. That is nothing but the energy consumed by an electrical appliance in 1 hour. So it is said to be the kilowatt hour there. So this is called, in particularly in the electrical energy, it is called their unit, 1 unit. This kilowatt hour is said to be the 1 unit. Kilowatt hour is, it is known as 1 unit. So then while calculating the electrical bill, so which it will be generated by the electricity board. So how many kilowatt hours of energy has utilized per day, per 1 month, per month, okay. So we see here 1 kilowatt hour, it is treated as here 1 unit. Then like that how many units it has consumed. In a whole house, how much amount of units of energy has consumed. So the government will be decide for 1 unit certain amount of cost. Then if you multiply that to this kilowatt hour, then we'll get the electrical bill. Okay. So here we'll see there 1 kilowatt hour, how many joules there. So it is commercial unit of electrical energy, and it is known as 1 unit. Then we should convert this kilowatt hour into joules there. So kilo is nothing but 1000 watts. 1000 watts. Kilowatt is nothing but 1000 watt. and hour is how many seconds here? Hour. And again here this watt is nothing but joule by second, joule per second. And this one is here 1 hour is 3600 seconds. Now second and second will be cancelled there. The total will be converted into the joules. So here we can write there it is so 36 into 10 to the power of 5 joules we can write there, or it can also be written as here 3.6 into 10 to the power of 6 joules. Okay, so therefore the commercial unit of electrical energy in terms of joules, the commercial unit of electrical energy 1 kilowatt hour is equals to 1 kilowatt hours. So this 1 kilowatt hour is equals to, we can write here, therefore so 1 kilowatt hour, 1 kilowatt hour is equals to 3.6 into 10 to the power of 6 joules. So if any electrical appliance is consumed this 3.6 into 10 to the power of 6 joules of electrical energy, then per hour, or like that how many joules of energies it is consumed. So based on that it can be calculated there. Okay. So this is about the electrical commercial unit of electrical energy, commercial unit of electrical energy there. Okay. So now we'll see there here. So what is the definition of this commercial unit of electrical energy? 1 kilowatt hour. It is nothing but the energy consumed, the electrical power consumed by the electrical appliances in 1 hour is said to be the 1 kilowatt hour. So 1 kilowatt hour there. Okay. So now we'll see the relation between here, already we have found there the relation between the kilowatt hour and the joules. So 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. Okay. So now we'll see there this energy is in, there are many forms of energies. Okay. So we'll see there the forms of energies now. Forms of energies. There are different forms of energies are there now. So we'll see here mechanical energy, potential energy and kinetic energy based on the state. Okay. So we'll write here types of energies, types of energy, types of energies. Okay. So there are basically, first one is the potential energy, and it is known as P, and next second one is the kinetic energy, so this is said to be the Ke, and third one is the mechanical energy, so mechanical energy. So now here what is the potential energy, we'll see there one by one, we'll see there. So now we'll see there first one now potential energy. So potential energy is what there? Potential energy. These forms of energies, this type of energies are based on the position of the body there. Okay. State of the body, whether that is in the state of rest or motion, based on that this type of energies are there. So now the potential energy we'll see there here. The energy possessed by a body by virtue of its state, okay, is known as potential energy. The energy possessed by a body by virtue of its state, its position, its state or position is called potential energy. Okay. So that means suppose if an object is there here, so we'll derive the equation for this potential energy. Okay. So we'll derive the potential energy. Derivation of potential energy. We'll see here now. Okay. Suppose any object, so I'll draw here, I'll do it there. So if an object is lifted, suppose if an object is there on the ground and it has a mass m. Now this body has lifted to here. up to here to a certain height h. This has lifted to certain height h. Okay, so when it has lifted there, the weight of this will be always act downward direction, and the here displacement is h. So now we know that work done is nothing but what there work done. W is equals to force into displacement we can write here. So here the displacement is s and this will be the force. So then W is equals to what can write here? Mg force. F is nothing but okay. W is equals to F into S. No, F is nothing but here mg and displacement is here h. So W is equals to mg h. That work done. So to change its state, whenever the position of the body has changed, so that there we have to do certain work done. That work done will be stored in the form of energy in the body there. Okay. So that energy is called that energy possessed by changing its state, changing its position. So that is called the potential energy. The energy possessed by a body by virtue of its position is called the potential energy. So now here this W work done will be stored as a potential energy in the body. So we write here the expression of the potential energy is mgh. Expression of the formula of the potential energy is mgh. Okay. So this is about the potential energy. That is about potential energy. Okay. So potential energy nothing but the energy possessed by a body by virtue of its position is called the potential energy. Certain object of mass m is lifted to certain height there. Then so the due to the change of its state there. To change of its state, we need to apply the force. That force will be due to that force. There is a work done will be takes place there. That work done will be stored in the form of in the body as energy there. So that energy is known as potential energy. So the energy possessed by a body by virtue of its position is called the potential energy. Okay, this is about the potential energy. Now we'll see there here kinetic energy. Okay, so kinetic energy we'll see now. Next one is the kinetic energy. So now when a body is so here in the potential energy we change the state of the body there. Okay, so then here kinetic energy means if the body is in the motion. Okay, if the body is in the motion there, then so it has there is a work done will be takes place there to bring the body. We need to apply the force. That force will be having the work done on the body there. So that work done will be stored in the body as the energy. That energy is called the kinetic energy. So here we can define this kinetic energy is the energy possessed by a body by virtue of its motion is called the kinetic energy. So okay. So whenever the body is, it is in the motion there. Suppose the marker is there. If I throw it, means it will be coming into the motion there. Okay. So whenever it is in the motion there, so it will be get certain energy there. So that energy is called as kinetic energy. Okay. Suppose if m mass of the object is moving with the velocity v, then the energy stored in the body, is said to be the kinetic energy. That kinetic energy expression is given by here mv square. So half into mv square. Kinetic energy is half into v square. Now we'll derive the equation. So derivation of kinetic energy. Derivation of kinetic energy. Okay. So here, suppose let us consider an object of mass m is there on the ground and certain force is applied here. That force will be changes the displacement of this body. So the body will becomes here. Okay. So initially the body at rest there, it is u is 0. So after displacing the displacement s, the body will be get the velocity v here. Final velocity will be get there. Okay, the body will be get the final velocity. So then here Then the work done. So work done, what will say here? Work done taking place. Work done on the body. So work done on the body is written as here W is equals to F into S. We can write here F into S. Then F is nothing but here mass into acceleration. We can write there this. If a force is applied, it will be moved with certain acceleration there. Okay. Then here yes, how to write there? Initially the body has at rest there. So from this we can write here, since from third equation of motion, v square minus u square is equal to 2as. So from this v square minus u square is equals to 2as. So from this here v square is equals to v square minus 0 whole square is equals to 2 into a into s. So now here v square is equals to 2as we can write. So from this s square is s is nothing but v square by 2a will come there. Now this s, if you substitute here in this equation, then w is equals to what you can have, what can we write here now? So m into a, s is nothing but here v square by 2a we can write. Now this a and a will be cancelled there. The work done will be written as here half into m into v square we can write there. Okay, half into m into v square. Now that work done will be stored in the body as the energy, that is a kinetic energy. So therefore now the kinetic energy expression is half into m v square, half into m v square, half into m v square. Okay. So now we have the relation between this kinetic energy and the momentum. Kinetic energy, see here, kinetic energy is directly proportional to v square when the mass of the body is constant. Mass of the body is constant, it will be directly proportional to the v square, velocity. Okay. And if the velocity is constant, it is directly proportional to the mass. Okay. So now here we will write there the relation between the kinetic energy and the momentum. Okay. So kinetic energy and the momentum, we will see here. Afterwards, we will discuss the potential energy. Okay. Kinetic energy and the momentum. So what is the momentum? Already we studied in the Newton laws of motion. Okay. So momentum is nothing but product of mass and velocity is called momentum of the body there. Okay. It is the product of mass and velocity. It is the product of mass and velocity. Then here, so we'll write here now the relation between linear momentum P and K, kinetic energy. Linear momentum P and kinetic energy. So we write here. Yes. So kinetic energy is written as here half into m v square. Okay, now here P is equals to, we can add there m into v. So now above this kinetic energy, if it is divided by m v square divided by mass and multiplied by mass there. So we can write here kinetic energy is equals to half into mv whole square we can write by m. So here m is nothing but what there from this. So kinetic energy Ke is equals to, we can write here. So half into p square divided by m. That is nothing but here p square by 2m we can write. So therefore kinetic energy Ke is equals to, we can write here p square by 2m. P square by 2m. This is the relation between kinetic energy and the, this is kinetic energy and the momentum. So what is the momentum here? How it is related? Kinetic energy is directly proportional to square of the momentum when the mass is constant, and this is here the mass is constant. Mass constant. This is a constant value. If it is a constant there, then this is the equation we will get here. Kinetic energy is directly proportional to momentum, square of the momentum. And second one is kinetic energy is inversely proportional to, kinetic energy is inversely proportional to mass. That is nothing but 1 by m when P is constant there. When P is a constant. Okay, when P is constant. So by using that, we will have the numericals. We can do it now then. Next, so this is, and next one is here mechanical energy. So mechanical energy is nothing but, so third one is there mechanical energy. So mechanical energy, MER total energy we can add there. MER TE we can add there. It is the sum of the potential energy and kinetic energy. So ME is equals to, we can write here ME is equals to potential energy plus kinetic energy. Potential energy. Sum of the potential energy and the kinetic energy of the body is said to be the mechanical energy or total energy. Okay. So this is about the mechanical energy. All the energy will have the same SI unit. Okay. And dimension formula. Now we'll see their concept based questions and then exercise problems we'll do there. Okay. So here practice sheet 3 concept based questions we see here. The relation between kilowatt hour and joule. We have seen there now kilowatt hour joule. 3.6 into 10 to the power of 6 we can write there, or 36 into 10 to the power of 5 we can write there. Okay. Option C, kinetic energy is depend on position, speed, shape, color. It is depend on the speed of the body. And if the work done by a force on a body is negative, the kinetic energy will be remains the same there. Kinetic energy does not change there. Work done is okay same. The SI unit of energy is called, SI unit of energy is joule, kinetic energy of the body of mass m and the velocity is v. Kinetic energy formula we have here, half into mv square. Which of the following is not unit of energy? So here all are kilowatt, all are unit of energy, is not unit of energy they said there. Newton meter is also energy only, joule unit of joule is also unit of energy, Newton meter also unit of energy, kilowatt is not a unit of energy. So it is a power, watt is nothing but the power, joule per second, no, it is. So third one is the answer there. A man is climbing a staircase, the energy is uses does not depend upon the the height of the staircases and the weight of his body, the time taken to reach the top, the mass of his body there. Okay, the energy does not depend the time taken by the body to reach the top there. So it is depends on the position, state of the body only. Okay. So option is 3 here. Kinetic energy of the body is increased most by doubling its kinetic energy of the body is increased doubling its speed. Okay, if it is the speed of the body is double, then the kinetic energy will be double there. Okay. So next exercise problems we'll see now. Exercise problems. Okay. So exercise 1 we'll see here. Exercise 1. First question is given here. A vehicle of mass 1000 kg has a kinetic energy 20,000 joule. Then velocity at that instant is velocity of that body at that instant. See here, mass of the body is given there. First question. First question is given here. So m is equals to 1000 kg is given there, and the kinetic energy work done or the kinetic energy is given here. So kinetic energy K is equals to kinetic energy is 20,000 joules. 20,000 joules is given there. They are asking the velocity. So kinetic energy formula we know that is half into mv square. Kinetic energy formula is half into mv square. So now kinetic energy heat is given there here 20,000. So we write here 20,000, that is equals to half into m is how much there here 1000 and it is v square. Now this 3 zeros and 3 zeros will be cancelled there. So it will come this side, it is become 40. 40 is equals to v square. So from this we can write here v is equal to square root of 40. How can we write the 40 here? So it can be written as 8 5 means here root 8 means. So we can write here or 4 into. So we can write here this is 2 into root 10. 2 into root 10 meter per second. So therefore velocity v is equals to 2 into root 10 meter per second. This is the answer there. That is the answer. Okay, velocity. So next question we'll see here. Second one. Second solution. Second solution is also same like that, only you can do it there maybe. So mass of body is 2 kg thrown upward with initial velocity 20 meter per second. After 2 seconds, its kinetic energy will be. After 2 seconds, its kinetic energy, we need to find out that. So after 2 seconds, what is the velocity of the body? We need to find out so that we can find out there, okay. So mass of the body is given there here. Second one, mass of the body is 2 kg is thrown upward. 2 kg, mass of the body is 2 kg. It is thrown upward with a velocity here 20 meter per second. 20 meter per second. And after 2 seconds, its kinetic energy. So we should find out here velocity, and g is given here 10 meter per second, 10 meter per second square. So to first we need to find out the velocity at the 2 seconds, okay. So velocity at the 2 seconds means v is equals to u plus at, we can write here, ab is nothing but gt, will write here minus, okay. Now v is equals to, it is 20 minus 10 into, so we can write here what is 2 seconds, 20. So here v is equals to what can we write there, 20 minus 20, so v is equal to 0. If v is equal to 0, the kinetic energy after 2 seconds will become 0 joules. Answer is here now 0 joules. Answer is 0. Okay. So this is the answer there. Answer is 0 joules. Two bodies of equal masses move with uniform velocities v and 2v respectively, the kinetic energy, ratio of kinetic energy. So here the kinetic energy they are asking there. Third one, in the third problem, third solution it is given there. In the third solution, so two bodies of velocity is given there, two bodies of equal masses. That means here m1 is equals to m2, that is equals to m equal, and v1 is equals to here v, and v2 is equals to 2v is given there. Then they are asking the ratio of the kinetic energy, So kinetic energy formula is what there here, half into m v square. So it is a constant mean kinetic energy is directly proportional to v square here. So k1 by k2 we can write there. This is a kinetic energy. v1 by v2 whole square we can write now. So v1 by v2 means v square by 4v square it will become there. So therefore k1 by k2 is equals to here 1 by 4 it will become. That means here k1 is to k2 is 1 is to 4. 1 is to 4 is to, that is the answer there. So answer is what there? 1 is to 4, option 4. Okay. So next here fourth one we will see there, fourth solution. 20 kg of mass velocity is given here. So certain instant kinetic energy they are asking there. Kinetic energy. Okay, so there 20 grams is given there mass, 20 gram of mass, and here unit vector is given there. So we can do it like this. So we should find out the magnitude of that vector. In the vector chapter we have seen now how to find out the magnitude of the velocity. So by using that we can do it there. So fourth one here, fourth solution, mass of the body is given here 2 kg, 120 grams. So 120 grams we should convert into kgs. So how much it will become there? 0.12 kg. 0.12 kg. Okay, here 1 gram is 10 to the power of minus 3 kg. Substitute there, we'll get that one. Means 120 by 1000. 120 by 1000 means here 0.12 kg will get there here. And the velocity vector is given there. Velocity vector, what it is given? There is a 2 I cap plus 5 j cap. 2 I cap plus 5 j cap meters is given there. So now we should find out here magnitude of this. There is nothing but square root of 4. That means here 2 whole square plus 5 whole square we can add. That is 4 plus this one is 25. So here v is equals to, we can add here root 29. So then from this here v square is equals to 29 we can add there now. V square is equals to 29. Now the kinetic energy formula is what there? Kinetic energy is equals to half into m v square. So half into m value how much there? 0.12. And here v square is 29 is given there, 29. So how much it will become there? 0.06. 0.06 will get there. Okay. So that is 1.2. So we'll get here, multiply this one. If you multiply, we'll get the answer there. So how much we get it there? So 29 into 0.06 This is a 54 and here 12. 17 will get here. 17 means then here will get there after 2 decimal point. 1 point. So the answer is 1.74 joules. So the kinetic energy is what there? 1.414 joules. Kinetic energy is 1.414 joules there. That is the answer. Okay. As body rolls, fifth one is given there, rolls down inclined plane, it has only kinetic energy, only potential energy, both potential energy and kinetic energy has no energy. Okay. So rolls down, it has a both potential energy. Whenever it is at the starting position, at the inclined plane, top of the inclined plane, so it has a potential energy. Whenever it is comes down, whenever it is moving there, it has the kinetic energy there. At the bottom, kinetic energy only present there. At the top, potential energy only present there. So while it is moving, rolls down, both energies will be present there. So next one is a force of 8 Newton is applied on a body of mass 2 kg at rest for 10 seconds. Kinetic energy is here. Okay. So a force of 8 Newton is applied on a body of mass 2 kg at rest for 10 seconds. Then the kinetic energy. So a body of mass, so force is applied here. So if the force is applied, how much we get there here? So mass, 8 newtons of the force is applied on 2 kg mass, then the acceleration will get it there here. 4 meter per second acceleration will get there. So then if acceleration is there, what is the velocity will get there? Acceleration is 4 meter per second there. So here acceleration is velocity by time. So here 4 is equals to v by t, then velocity is equal to 40 meters will get there. Then, so 2 kg into, we can write here 40, so 160, we'll write like this, okay. Sixth one we'll see. Sixth problem. In the sixth question, the force is applied here, F is equals to 8 newtons. F is equal to 8 newtons, okay. Then, and mass of the body is 2 kg. Then we will get here from this F is equal to m, A is equals to F by m, no? F by m. How much we get there? This is 8 divided by 2. We will get there 4 meter per second acceleration. How much time that is applied there here? T is equals to 10 seconds. If T is equal to 10 seconds, what is the velocity we will get there? Velocity is nothing but A to T we can write now, because A is nothing but v by t. So from this, we'll write here 4 into 10. So we'll get here 40 meter per second. Velocity is 40 meter per second. Now the kinetic energy. Kinetic energy is equals to half into mv square. No? So half into m is what here? 2 kg, and this is a 40 whole square. 40 whole square. 2 will be cancelled here. How much will get there? 1600 joules. So therefore, the kinetic energy is equals to, we'll get here 1600 joules. 1600 joules. That is the answer. The answer is how much there? 1600 joules. So seventh one is given there. Two spheres of different materials are in motion. If their densities are in the ratio 1:2, radius are in the ratio 1:2, velocity are in the ratio 2:1, then kinetic energy. Two spheres of different materials are the densities are in the ratio is given there. Densities are in the ratio is given, and the radius are in the ratio is given there. And velocities also is given. Their kinetic energies are in the ratio they are asking there. Two spheres. So we'll do it like this. So kinetic energy expression, seventh one we'll see here, it is an important one. So kinetic energy is equals to half mv square. So kinetic energy is equals to, mass is nothing but in terms of density, what can we write there? Mass. Mass is nothing but density into volume into v square. Volume is nothing but again area into length. This is a volume now. It is a volume. This is a volume there, v. That means here k is equals to, here half into rho into, here a into h we can write there. It is a v square we can write there. So A again here kinetic energy is equals to half into rho is the density, and it is A is nothing but, so pi r square of spheres now, area. Or we can write here, if you take consider their volume there, okay. So they given the radius, no volume. Directly we can consider here volume of the sphere there. No need to consider this one here. There is a 4 by 3 pi r cube we can add here. Pi r cube into v square we can add there. So then kinetic energy is equals to, we'll write there 2 by 3 into rho into 2 pi by 3 into rho into r cube into v square we can add there. R cube into v square. Now, so if this is a constant then no, so kinetic energy is directly proportional to, kinetic energy is directly proportional to density and radius of the body and velocity of the body there, okay. So now here k1 by k2, k1 by k2 is equals to rho 1 by rho 2 we can add here, r1 by into this into r1 by r2 whole cube we can add here. So here v1 by v2 whole square we can add there. So now from this k1 by k2 is equals to, densities are given in the ratio 1 is to 2 now. In the question densities are in the ratio 1 is to 2, means 1 by 2 we can add here, and the radius are in the ratio also 1 is to 2. So it will become 1 by 2 whole cube we can add there, and velocities are in the ratio 2 is to 1, 2 is to 1. So here 2 by 1 whole square we can add there, okay. So what it will be happen here now? So kinetic energy, I will do it here. Is it seen here? So I'll write the equation here. This one. So k1 by k2. k1 by k2 is equals to, so 1 by 2. 1 by 2 into 1 by 8 we can add there. Okay. So 1 by 8 how we can add there? This is a 1 by 2 whole cube into 2 by 1 whole power 2. So now from this here k1 by k2 is equals to 1 by 2 into 1 by 8 into 4 by 1. So this is here 1 are 4 1s are 4 2s are. Okay. So here we'll get this value is 1 is to 4 there. So 1 by 4. So then therefore k1 is to k2 is equals to 1 is to 4 ratio. 1 is to 4. The ratio of this is 1 is to 4. Okay, 1 is to 4. First option. So next question, 8th one. The mass of the body. Next question we'll see here. The mass of the body is halved, velocity is doubled, percentage increase in kinetic energy of the body there. Okay. So percentage increasing. 8th one will do that here. Percentage increasing in the body. So 8th question, 8th solution here. 8th solution is given here. A mass of the body is halved, means mass of the body is halved means m2 is halved, m2 is m by 2, m1 by 2, and velocity is double. That means your v2 is equals to v1, 2v1. So from this we can add here m1 by m2 is equals to, m1 by m2 is equals to 2 we can add here. You bring this m2 this side and send 2 that side, m1 by m2 is 2 will get, and from this v1 by v2. So v1 by v2. So v1 you bring this side and it will become 1 by 2 it will become there. So now they are asking the kinetic energy, ratio of their kinetic, percentage increasing in kinetic energy. So now here k2 by k1 we can add here. So generally the kinetic energy formula is what there, kinetic energy is equals to half into mv square, half into mv square. So here the kinetic energy is directly proportional to mass and here velocity. So we can add here. So k1 by k2 is equals to m1 by m2 into v1 by v2 whole square we can add. Okay. Or here k2 by k1 we can add, k2 by k1 is equals to m2 by m1 into v2 by v1 whole square we can add here now. So now from this, so k2 by k1 is equals to, what can we write here? Mass. m2 is what is given there. So m2 by m1 here 1 by 2 will get 1 by 2 because here you bring there m2, reciprocal of this is 1 by 2 it will become there, m2 by m1, m1 by m2 is 2 no. In the same way here v2 by v1 is 2 you will get there, v2 by v1 square. That means from this k2 by k1, k2 by k1 is equals to, here we will get there, this 2 and 2 will be cancelled no? So 2 remains there, 2 is to 1. So now they are asking the percentage increasing here. So k2 by k1 minus 1 is equals to here 2 minus 1 we can do. So that means from this k2 by k1 divided by k1 into 100 if you do here. So here 1 will be there, it is a 100%. So the percentage increasing. Therefore, here delta ke, percentage of delta ke is increased by 100%. 100%. It is increased by 100%. So fourth option is correct there. So ninth one is given, on increasing the speed of the body 2 meter per second, its kinetic energy is quadruple. Then the original speed must be, okay, on increasing the speed of body to 2 meter per second, on increasing the speed of the body 2 meter per second, its kinetic energy is quadrupled, means kinetic energy K2 will become 4 times, okay, 2 meter per second, increasing the speed of a body 2 meter per second there. So then the original speed of the body they are asking there. Increasing the speed means, so 2 speed of the body to 2 meter per second there. On increasing the speed of a body to 2 meter per second. So increase the speed of the body to 2 meter per second there, okay. So then that means V2 is 2 and V1 is V, we can write there. So now we can write here remaining, okay. So we'll do it now here. V2 is increased to 2. So this is the ninth solution. So V2 is increased to 2 meter per second, and V1 we can write here V only. V1 is V1 only, or V we can write there, okay. Then kinetic energy K2 is quadruple, means 4 times of K1. Okay, they are asking what is the initial speed. So initial speed they are asking there. So here kinetic energy is directly proportional to V square, no? So K1 by K2 is equals to, we can write here V1 by V2 whole square. So here K1 by K2, how much we get there? This is a 4, no? And V1 by V2. So V1 is what there, V here, divided by, this is a 2. So it will become how much there? So 4. So V is equal to how much we get there? 1 meter per second. V is equals to 1 meter per second. Simplify that here. So V square by 4. 4 will be cancelled, 1 only, root 1 is 1 only. So 1 meter per second. 10th one is given here, two bodies A and B have their masses are in the ratio 3:1, kinetic energies are in the ratio 3:1. There the velocity, same formula we can use here, this formula only. So by using this formula, by using this one, we can do it there, you do it there. So 10th one you can do as a homework. And 11th one you see here, the velocity of ball of mass 200 grams at an instant of 5 centimeter per second, then the kinetic energy will be, the velocity of a ball of 200 grams at an instant is 5 centimeter per second, then it's a kinetic energy. So they given here, all are given in the CGS units only, then we can write kinetic energy, what can we write there? Half into mv square. M is given here and V is given there. So we can do it there. Okay, an empty car. So 12th one is given here, an empty car weighing with certain velocity on frictionless road it can be stopped at a distance of, yes, if the percentage, if the passenger add 40% of its weight, the same braking force is applied, then stopping distance of the velocity will be, we should find out that. An empty car moving with a certain velocity on frictionless road can be stopped in certain distance, yes. If the passengers add 40% of its weight, the same braking force is applied, then the stopping distance we need to find out that, okay. So how to find out the stopping distance? Same. So here we'll write like this. So here this is the question is here, it is a 12th one. An empty car is moving there, okay. So kinetic energy is depends on mass of the body and braking force, mass of the body and here braking, okay, same braking, mass of the body and the velocity of the body, okay. So the velocity will be, they are asking the velocity there, okay. So on frictionless, this one, Kinetic energy is equals to, we can write here half into mv square, half into mv square. Okay, half into mv square we can write there, kinetic energy half into mv square there. Okay, here v is nothing but k is equals to, we can write here now, that is half into here v is nothing but in terms of it will be stopped, it will be started from the rest if we consider there. So the stopping distance here we can add there, this is a m into here we'll write here v square by here v square is equals to 2 into a into s we can add there, v square is equal to 2 into a into s. So kinetic energy is equals to, we'll write here this 2 will be cancelled here, m into a into s we can add here, stopping distance. So now the kinetic energy is directly proportional to the stopping distance, mass of the body it is and the distance. Now here weight of the body is added, 40% of weight of the body is added there here, 40% of the weight. So now here this can be here it is moving with acceleration, no, it does not depend on the weight of the body now. The body, if it is moving means acceleration will be there. Okay, so then the kinetic energy will be, so 40% of its stopping distance they are asking there now. Okay, so then what will be the kinetic energy? Stopped in a distance, yes, if the passenger add 40% of its weight, same braking force is applied there, same braking force, this F is equals to, so here we can write here this one. Okay, then kinetic energy K is equals to F into S we can write here, F into S. So this force is same there. Then the distance we should find out there. Okay, so now the kinetic energy is here, it will be, kinetic energy does not depend on the weight of the body now. Okay, so how to take here weight of the body? 40% of its weight there. So means W2 is equals to W1 plus 40% of its weight. W1 it is added. So now it is, we can write here W2 is equals to W1 plus here 0.4 W1. So that means 1.4 W1 we can write here. So W2 by W1 is 1.4. Okay. So then weight of the person is this one. So it is 1.4 times of this one. So but here the kinetic energy. So here F we consider here weight of the body. F is equals to mg if we consider there. Okay. So this kinetic energy does not depend on the weight. So it will be stopping distance. Stopping distance is asking there. So now distance we can write here so from this equation we can do like this, half into m v square that is equals to mg into s if you write there here. So v square is nothing but we can write here v square is equals to mg. Kinetic energy is that one. No? So here if the kinetic energy is constant, then same braking force is applied. Kinetic energy is constant means here S1 by S2 is equals to W2 by W1 we can add that. Now here the stopping distance. So S1 by S2 is equals to, from this we can add here W2 by W1 we can add that. Now the stopping distance S2 by S1 is equals to, we write here W1 by W2. So from this S2 by S1 is equals to, W2 is what here, W2 by W1. So here 1 by 1.4 we can add here. Then S2 is equals to S1 by 1.4. S1 by 1.4 we can add there. So it will be decreases by, so S by, so here that is nothing but S by 1.4 we can add that. S by 1.4. So the answer is here now S by 1.4. W2. Okay. So next numerical type is there. If the kinetic energy possessed by a body of here, so we can find out speed, that we can do there. They are asking here the kinetic speed is given, the mass of the body is given, and kinetic energy is given. Then we should find out the speed there. So next in the 14th one, a man has a box of weight is given there. Energy in the box when a man runs with velocity 2 meter per second along with the box behind the bus in joules there. Okay. So a car is moving with velocity is given there, kinetic energy of the body. So we can write on 15th one, we can do there. A man has a box of weight 10 kg. The energy of the box when the man runs with a constant velocity 2 meter per second. Okay. So then mass is given and here velocity is given there. So we can add the formula there. Okay. Now here it will become 10 into, so 4 it will become 20. 20 joules will get there. Okay. So you can do it there simply. So this is the concept synopsis 3. We have completed synopsis 3. Then next in the next synopsis 4 we'll see in the next class there. Okay. So this is about the synopsis 3, about the energy and types of energies, potential energy and the kinetic energy, and we have done the numericals. Okay. In the next class we are going to complete this chapter, and afterwards we are going to see next chapter there. Okay. Thank you children. Have a nice day.